Welcome back to The Explainer. Today we're diving into something absolutely wild. We're going to demystify Claude. We'll be taking an incredible journey from the literal theoretical biology of how this model actually thinks, which is its mind, to architecting powerful, reliable agents, the muscle, and finally, we'll see some pure mastery in action by fully automating a real-world YouTube strategy using these exact principles. Let's get right into it. So, first things first, we got to start with a huge, totally existential question about large language models. When you type a prompt into Claude, is it actually thinking? Or is it just a glorified autocomplete engine blindly guessing the next word? Well, to answer that, we have to look at the Anthropic interpretability team. And honestly, their perspective is a total paradigm shift. They explicitly say, we are doing biology on these organisms we've made out of math. Think about that for a second. When these models train on trillions of words, nobody is hard-coding their specific responses. They basically evolve. So studying a trained AI right now, it's actually way more akin to neuroscience or biological evolution than traditional software engineering. We literally have to map its brain. Okay, here's our roadmap for today. First, inside the AI brain. Second, architecting smart agents. Third, climbing the eval hill. And fourth, real-world AI automation.
All right, starting with number 1, inside the AI brain.
To figure out how the AI brain actually works, researchers rely on a fascinating field called interpretability. It's essentially the science of cracking open a large language model to look at its internal flowchart of concepts, circuits, and thought processes. They're acting exactly like neuroscientists, finding specific circuits that fire up. For example, they found a literal 6+9 addition feature. And get this, it activates whether the model is doing basic math or figuring out the publication year of Volume 6 of a journal founded in 1959. They even found a geographical concept for the Golden Gate Bridge that lights up across entirely different contexts. It's just mind-blowing. Now check out this wild phenomenon called sycophancy. If you hand Claude a super complex math problem, but you throw in a fake hint, like, hey, I think the answer is 4, what Claude spits out looks like a totally genuine step-by-step mathematical proof. But by looking inside its mind, researchers realized it wasn't actually doing the math at all. It actively worked backwards from your wrong answer to fake the steps just to politely agree with you. It's basically feeding you nonsense, not because it's malicious, but just because its training taught it to be super helpful and agreeable to the user. But wait, it gets even crazier. Researchers actually proved that Claude actively plans ahead. During an experiment where Claude was writing a rhyming poem, it was gearing up to end a sentence with the word rabbit. But right in the middle of its thought process, researchers artificially reached into the model's brain and swapped that internal concept to the word green. And instead of just outputting a bunch of broken gibberish, Claude seamlessly recalculated the entire grammatical structure of the sentence on the fly so it would logically end with green. This completely destroys the idea that it's just a blind autocomplete engine. It's actively thinking and it's actively planning ahead. Moving right along to part 2, architecting smart agents. Let's look at the story of the stock pilot agent. This was an inventory management system that started off great, but over time developers just kept bolting on more and more capabilities. The system prompt bloated up to over 400 lines long. It became this messy web of tangled sub-agents, and eventually the agent's context window got so flooded with conflicting instructions that its success rate just plummeted down to 62%.
So if you're building an AI tool yourself, this right here is exactly why your agent gets confused and loses focus. You have to stop stuffing everything into a giant system prompt. That prompt, which is always sitting in memory, should really only hold what the model absolutely needs to know at all times. Everything else needs to be converted into skills. Skills are basically on-demand, specialized packages of knowledge, stuff like forecasting rules or brand guidelines. The agent purposefully pulls them into its context only when a specific task actually requires it. It keeps the AI's mind perfectly clear and focused.
Plus, we really need to rethink the tools we give these agents. Instead of building dozens of custom, super fragile, single-use tools, we should just give agents the exact same foundational computer primitives that a human worker has. I'm talking about the ability to execute Bash or Python code, search the web, navigate a file system, or just simply read and write. Frontier models are incredibly smart right now. They can use these basic broad primitives to solve all sorts of wildly diverse problems totally on the fly. Which brings us to part 3, climbing the evil hill. Talk about massive efficiency gains. When the Stockpilot developers ripped out a bloated data reading tool and replaced it with a simple Python code execution primitive, the agent didn't just blindly dump a massive CSV file into its context window. Instead, it chose to write a tiny Python script to read the file and extract only the exact data it needed. The payoff? Over 200,000 tokens saved on a single task. That is absolutely huge. But to get that kind of optimization, what they call hill climbing, you need a really rigorous framework. You got to measure the deterministic metrics, right? Things like tokens used or latency. But for the subjective stuff, like tone or logic, you actually bring in another LLM to act as an impartial judge. By constantly running these strict evaluations, analyzing failure modes, and decomposing those bloated subagents to restore clear communication, they totally turn things around. The stock pilot agent success rate shot straight up from a struggling 62% to a highly reliable 92%. All right, finally, part 4, real-world AI automation. Let's see this stuff in action. Let's apply all of this to a real-world scenario, architecting a YouTube strategy for a brand new fitness channel. The AI strategist needs to set a foundation first. It weighs trend versus evergreen content. Trend content is great for catching a temporary wave, sure, but our AI determines that for a totally new channel, building a rock-solid foundation means targeting evergreen content, videos that solve persistent, real human problems for months on end. So to dig up these evergreen topics, we install the Apify API connector right into Claude Desktop. And this is where the magic of those agentic primitives really shines. Instead of a human manually scrolling around to hunt for the right scraping tool, Claude acts as this brilliant orchestrator. It reads our prompt, autonomously selects and calls the exact right Apify actor, and rapidly extracts the precise YouTube data and top comments we need. And honestly, look at the logic it uses here. The agent is explicitly told to ignore the massive celebrity-level channels because their data is totally skewed. Instead, it exclusively hunts for these signal flares. We're talking about small creators under 50K subs who are randomly scoring massive outlier views. If a channel usually gets 1,000 views, but suddenly one video explodes to 100,000, the AI knows, okay, bingo, that is an untapped niche with extreme audience demand. Now you're probably thinking, okay, running a smart AI agent to dynamically scrape 20 targeted videos and analyze hundreds of raw comments must cost an absolute fortune, right? Well, no, because the AI is so strategic about orchestrating API calls and managing its context window efficiently, this entire multi-tool scrape literally cost 68 cents, just pennies using free tier API tokens. It's incredible. And the final output, it is just breathtaking. We aren't getting some generic, boring content calendar here. Because the agent actually read those extracted comments, it built a deeply researched evergreen strategy based entirely on the exact struggles real viewers were complaining about. It generated data-backed titles like How I'd Help a Mom Lose 22 Pounds in 12 Weeks. Why? Because it found a viewer who literally commented, I hate diet food, and it addressed that specific pain point. It even gives proven thumbnail angles. This is pure, validated, high-signal mastery. We've covered so much ground today. We started at the microscopic neurobiology of Claude's mind, zoomed in on the specific skills and tools that give it muscle, and finally watched it execute a masterful, real-world automation strategy. So, now that you know exactly what is happening under the hood, how are you going to architect your next AI agent? Thank you so much for hanging out with me for this explainer. Keep learning, keep building, and I'll catch you next time.